All right. This is number 11, page 5 of your notes. Number 11, page 5. Let's do this way. You guys want to get in the video? Let's get you guys in. There you go. There you go. That should increase the ratings of my video greatly. If I keep this from year to year, like the next 10 years, you guys could be on this video. All right. So this is limiting reactant, but it is in grams. Okay, it is in grams, so it's not in moles. Okay, so here's your reaction. Sorry about the little numbers up top. What's your ratio here? This is a 1 to what? 1 to 4, but in moles. And I'm telling you this. I'm telling you, you got 240 grams of this. Put that right here. 240 grams, not moles. We need to get that into moles. And 200 grams of this. So if I ever give you both reactants, you typically need to figure out which one's going to run out first. So, and maybe they're in the right ratio. So figure out which one's going to run out first and who's the excess. Okay, let's figure out the limiting reactant. Remember, these would be 0 grams to start with, because until these start reacting, there would be none of them. Okay, so it'd be 0 of those. So let's convert these into grams. Let me do this up here. So 240 grams of SiO2. So just go grams. Convert grams to moles. So just divide by the grams in the correct table. And for SiO2, if you add up 1 Si and 2 oxygens, it is 60. I picked a number that works out well. What's 240 divided by 60? 4. Same thing as 24 divided by 6. Okay, 4. 4 moles. So I'm going to go over here. We're going to eventually going to make a little BCA table again. So before the reaction, we have 4 moles of SiO2. Does that make sense? So those 240 grams is 4 moles. Here's your before, do it before, change and after. Do the same thing with 200 grams of this. So 200 grams, and I picked numbers that are good here. 200 grams of HF. Go grams to moles. What's HF going to weigh? Fluorine's 19, plus 1 for hydrogen, 20. 200 divided by 20? Good job. So we know this value. This one's 4 moles, and this one's 10 moles. These would both be 0 and 0. With me there? So now let's try and figure out our change and our after in moles. I do want to know all the answers in grams at the end, but we can throw them into grams pretty easily. Okay. All right. So as you're doing this, it's supposed to be a 1 to 4 ratio. So here's what I would do. I'd go, okay, is 10 more than 4 times bigger or less than 4 times bigger? You guys can't see me. Less than 4? Mm-hmm. It'd have to be 16 to be 4 times bigger, right? Mm-hmm. So it's less than 4. So if it was more than 4 times bigger, I'd say it's excess. If it's less than 4 times bigger, I'd say it is the limiting reactant. That tells me then there's extra of this, or excess of that. So not all 4 moles of this is going to be used. In other words, not all 240 grams is going to be used, but we're going to use all 200 grams of this. So which one can we take completely away? HF. So we can go minus 10 moles. We know at the end there's going to be 0 moles of that. It's just going to run out. It's going to be used up completely. Only getting part of the screen. All right, now we got to figure out this. We got to figure out what this is going down by. And it's kind of weird because it's a 1 to 4 ratio. So
2.5. Is it 2.5?
So how'd you get 2.5?
10 divided by 4.
10 divided by 4, because this is 4 times less than that. You could always set up a little stoichiometry question and go, okay, well, there's 10 moles of HF being used, and for every 4 moles of HF, there's 1 mole of SiO2. So I'm taking 10 divided by 4, which is 2.5. So this is going down by 2.5. We're using 2.5. 4 minus 2.5 means there is 1.5 moles of extra left over because there wasn't enough HF to react with it. With me there? Mm-hmm. All right, let's figure out the other side of the equation. Or the other side. Remember, this is your arrow here. So these are your products. Now find ratios that are easy, if you can. Okay, try to find ratios that are pretty easy. and do this based on your change. So if this goes down by 2.5, I'm going to pick this one because it is a 1-to-1 ratio. I like 1-to-1s or 1-to-2s. If this goes down by 2.5, this one goes up by 2.5. So there's going to be 2.5 moles of the SiF4 at the end. So always base this on the change, not what's there before or after, what's on the change. Pick a ratio, it's easier. Actually, any of these ratios are fine. We can do 1-to-2. So what's 2.5 doubled? 5. Or you could do 4-to-2. This is half of that, and half of 10 is 5. So this is increasing by 5 moles, so there's 5 moles at the end. So typically you can find some ratios that are pretty easy in there. All right, now we need to get these into grams. I won't always make you put them in grams. Sometimes I will. We're going to put these in grams. So we need to turn this into grams. Just take your 1.5 moles of SiO2 and multiply it by what a mole weighs, which we know SiO2 weighs 60 grams per mole. So we'll just say a mole is 60 grams. 1.5 times 60 is 90 grams. That's your excess. That's how much excess is left over. Out of the 240 grams, we're using 150 of it. There's 90 left over. If you want to turn this into moles, just multiply it by, into grams, multiply it by grams in the periodic table. Let's turn the water into grams, just because we know what water is. 5 moles of water are made. What's a mole of water weigh?
18 grams.
Mole of water is 18 grams. 70 plus 40, 110. Most times we leave these in moles. There'll be some times we ask for grams, just so you know. All right. Hope the fourth period can figure that out off this video. We'll see.